folks, it's Sudesh, and I'm back for another episode of CloudStream. I'm pretty excited. I have someone who has spent, I think, their career in software development and has a lot of, I think, knowledge. Today's topic is really, how to go from a software developer to entrepreneur to I guess, startup investor. And also grad student. I'd like to welcome Aaron. Aaron, if you'd like to tell folks about yourself, it'd be great.
Sure, Sudesh. I'm the founder of Big Nerd Ranch is my big claim to fame. And Big Nerd Ranch was a training and consulting company. We wrote a bunch of books about iPhone and Android development, Mac development. And I have sold the company a year ago to a company called Amdocs. And now I'm a graduate student studying machine learning at Georgia Tech.
Nice. Now, Aaron, when we started chatting a little bit, we were talking about a bunch of different subjects, but I think the one thing that really fascinated me is I've been in enterprise tech for a couple of decades now, despite my youthful appearance, and it's interesting. A lot of times, I'll group us into corporate tech folk, right? We see these different opportunities in the startup world. We see these different entrepreneurial abilities, and in a lot of ways, you were at the ground floor of Apple in sort of the early days, and you got to see a lot of fun stuff there. What really kind of got me excited about this conversation was the fact that you could kind of tell us a little bit about kind of your transition, how you made some of those decisions, and a little bit of kind of early knowledge that maybe some of the younger folks who are listening, watching, may not even know about. And I thought that'd be great to share.
Sure. So let me give you a little history. So Steve Jobs, when he got booted out of Apple, started a company called Next Computer. And Next was going to be a big educational software computer thing. They made black computers that looked like Darth Vader would use them. And they pretty quickly pivoted into being an enterprise software company because they found that companies and government institutions could write applications much more quickly using the technology that was on Next. And I was, in fact, one of those people. So I was working on Wall Street at the time. I was working for a company called Wall Street Concepts. And I was a decent Next programmer. I had done some military stuff before that. And I went to work for Next Computer. I was, just a few yards from Steve Jobs' office. I worked in the training department. So I wrote courses on how to do development of applications that ran on the Next. So I knew a lot about the underpinnings of this software. And that was incredibly lucky. And I want to say right now, I'm going to talk about how great my life has been, how lucky I've been. A lot of it is luck. I worked hard. Yeah, I was willing to take chances, but I was really in the right place at the right time for a lot of stuff. And what I worked on at Next, what I taught people about, and what I programmed with before that, became the basis of iOS. So I knew the underpinnings of iOS programming in the mid-90s.
Wow.
So I was very definitely in the right place at the right time.
Yeah.
I was at Next and having a great time. I had a corner office. I had settled in. I was writing courses. I was a really important part of every product that rolled out. I was on the cross-functional team. And we got bought by Apple. And that's how Steve Jobs ended up back at Apple. But at the time, it was a big transition. And, they wrote me a check for all my stock options. And, and I was sitting in my office writing away at something, and in walked Kelly Toshak, and she had worked with me in the early days. She was in tech pubs.
Okay.
And she said, "Hey, Aaron, psychologists say people flourish when their chance of success is around 85 to 95% likely." And she said, if it gets below 85%, people start to feel desperate, and they do not do that well. If the chance of success gets over 95, then people get complacent and they don't thrive there either. And she said, well, where do you think you are on that chart in the new world? And I was like, it's probably like 99.7% chance of success.
So you're very comfortable here.
I was going to be successful. I knew my job and I was really good at it. And then Kelly just wandered away. She had no idea that she just dropped a bomb in my psyche. So for the next week, I was just like, it's true. I've really thrived when I've had to struggle. And that's one of the things that I would say to anyone planning their career is it's good for it to be difficult. That's where you grow. That's what keeps your job interesting over the long haul. And it's also what separates you from other people, is that you're the one who put in the time to figure this out and overcome it. People often, they get into college studying something like computer science or engineering, and then it gets really difficult and they give up.
Yeah.
And they go into exercise physiology or psychology or business or one of those other
not that there's anything wrong with that, but I think you have a point here that a lot of times, especially STEM subjects, are very difficult concepts because they require a lot of qualitative thinking, and that can be difficult, as well as the qualitative analysis overall. And I think it's as you consider your career path, being afraid of, I think, technical challenges is not something that you should really fear, right? It's kind of like I have a fear of small heights, right? I get above like 8 steps on a ladder and I'm like, woo! But you get me up 200 feet, I'm fine. I'll keep hiking. That's an interesting point that you made there. What were some steps that you took when you faced those difficult challenges? And I know you're also kind of already a great technical thinker, so maybe you had a couple of advantages in that arena.
Yeah, so you have to remember your successes, right? Is when you're learning something new, it's always hard and you always feel stupid. And you have to go back and say, I did this brilliant thing once. I must not be that stupid.
Right.
I'm going to keep going forward. Right. And as you get more and more momentum, you can look back on more and more of your successes and convince yourself that it's all right. Because that's the problem, right? Is your ego gets in the way. You start obsessing on, am I in the right place? Am I the right person? Am I dumber than I think I am? And that's when you start to lose out. The other thing is you need to make sure you get enough sleep. It's funny, as someone just last night tweeted about one of the things I say in my first book that I wrote, which is, this is difficult. You are not stupid. You have to remind yourself that all the time as you're going through this book. It's not going to be an easy book to read. It's difficult. It's hard. You're not dumb just because it feels hard. Yeah. Yeah.
No, I think the other thing is that you're really teaching software development, which, I'll say at a high level, not only do you have the technical side of software development, but you often have the philosophical side of software development, right? And to be at that level of, there's that DIKW, data, information, knowledge, wisdom, like staircase thing that a lot of professors trope out. But I think it's hard because a lot of times when you're learning software development concepts, you don't have wisdom or knowledge. You just have data or information.
Right. Especially when a technology is new, nobody has deep wisdom. I was lucky that I had a lot of experience with Objective-C was the language at the time, and the Next frameworks that were then part of iOS. I had that wisdom because I was in the right place at the right time for a long time. But when a new technology comes up, it's not clear how it's supposed to be used. And that's part of the big knowledge, is not just how can you use it, but how is it intended to be used? And there is a difference.
Nice.
Anyway, let me go on with the story. Yeah. So what I decided to do was to start my own company. I started a company called Big Nerd Ranch with my friend Emily. Okay. And I was the nerd and Emily was the business end of things. And we grew the company and it grew to over 100 people. And suddenly I went from the startup mentality, which is startup mentality is where you're trying desperately to start fires, right? Is that you're running around just like, if tomorrow is exactly the same as yesterday was, then we are going out of business. So you're always trying to start fires. And your big tension then is always, well, I got this phone call from SAP and they're going to get all this training from us. I hope I can hire fast enough. And you'd be up all night thinking about this incredible opportunity that was just about to happen. Yeah. And then it would never come to anything. Almost always, like 95% of the time, all these things that I thought were going to be a big deal. We were on Marketplace, the radio show. Apple reached out to us and did a partnership with us that they never then made public. And we had all sorts of ridiculous things that seemed like a really big deal and never came to anything. But then you get to a point where it has a lot of momentum. People know who you are. You have a lot of people. And then your job becomes putting out fires, right? People keep coming in and throwing things off. And what you're really hoping is tomorrow is going to be just like today was.
Right.
Because today was awesome. Like, we are over the hump. Today was great. Let's just keep doing it. And I think those are different types of leaders. So we were at 100 people, and I was not doing a great job of making sure that the sales team was properly motivated and supported. And so I turned it over to my COO, Stacy, and Stacy ran the company incredibly well. Yeah, but it's interesting when you look at leaders who are able to make that transition, and Steve Jobs is sort of the poster child. Yeah. He became whatever the organization needed him to be as we went through Next and then finally Apple.
Yeah, that's interesting. I think Hashi just went through something very similar. They had a CEO who moved back to just an individual contributor role. And he said, listen, I just want to do interesting engineering stuff. That's what I'm really passionate about.
I kept trying to do that. So Emily left and I had to step up and be CEO. So I made a big merger so that I could get a web team. And another guy who loved being CEO was like, you're CEO now, and I'm just going to write courses. And then that didn't work out so well. And so I stepped up back into the CEO role, and it was never my calling. I think CEOs are good managers or good leaders, and it's very rare you get somebody who's both. I think I was a good leader. I think I could put together a vision for the company and a strategy, and I could be reiterating the strategy as necessary. But I don't think I did a good job, setting up schedules and keeping people accountable and that sort of thing.
I mean, that is definitely, it's interesting because you talk about earlier how, you've got these challenges of learning a lot of the material that make you a good engineer or whatnot. But the flip side of that is that those amazing folks that are able to bridge the communications gap, the project management stuff, and then the leadership stuff can run the gamut. And it's tough. Yeah.
Right. And then there's the other thing, which is investor relations. So we were very lucky in that we accepted that we were going to grow slowly over the long term. So Big Nerd Ranch was around for almost 20 years before I sold it. Okay. So we could grow at a reasonable rate. Mathematically, you can only bootstrap at a certain rate. If you're growing so fast, you need to take investment. And then you have a third party to deal with, right? You have your employees, you have your customers, and you have your shareholders, and you have to keep them all happy. I never had shareholders. I was always the majority shareholder, and I didn't have to worry about investors. And I feel very lucky in that way.
Yeah, because we all know, or I guess that the popular show is Silicon Valley, where you get to see everyone's worst side on that show, right? Like that, nobody wants that. And
so I sold the company to Amdocs, which is a big publicly traded corporation. They wrote me a big check. And I've been at Georgia Tech studying machine learning. I just finished my master's degree. Thank you very much. And I'm working on a PhD now, studying how to use machine learning to make the power grid better, make it more reliable, make the power cheaper, make it cleaner. And that's a really interesting problem to work on.
So machine learning for the power grid, I mean, essentially the outcomes of that, like if we're 50 years in the future, are we thinking that, we're generating, power on a small basis that can be spread over, transmission lines to lots of different communities? Or are you even thinking further than that? What's kind of that future state look like? What's that?
Yeah. So the problem that we're grappling with right now, right, is what's called the net load.
Okay.
So you have the load, right? People want this much electricity.
Yes.
And then you have the renewables. And the renewables are this fluctuating here.
Yeah.
And so the difference between the two is the net load. And that's what you need to supply with thermal, hydro, and nuclear.
Right.
And as more and more of these renewables come online, which we all agree is a great thing, don't take my words out of context. It's a great thing, but it also destabilizes the power grid because that net load becomes more and more violent, right? It goes to zero now. And then on a cloudy day, you need just as much thermal, coal powered plants as you ever did.
Right. Because you have to keep the lights on.
Yeah. So making the grid stable as more and more renewables come on is a big challenge. And what happens is if we don't do it right, people leave the power grid, as most companies have done in Germany at this point.
Okay.
And you're left with a small number of people paying for the whole infrastructure, and it gets more and more expensive.
So essentially what happens is that the payers, most companies subsidize a large amount of the power consumed because they consume the power.
Right.
And so then you've got people like you and me, consumers, who are having to fit higher energy bills. Okay, that's interesting.
Yeah. So it's already happening, right? The military and Google have already set up microgrids and are no longer part of your grid and my grid. So it's a bad sign that we need to make sure that we make our grid as smart as we can,
as possible.
Yeah. So it's an interesting challenge, and it's something that has to be done in a very timely manner. So you can talk about stuff that's going to be 50 years in the future when there's big storage, for example. How are we going to optimize the storage on the network? But right now, utility scale storage doesn't exist, right? There aren't big batteries. Every time somebody needs an electron, that electron is put in the wire for them at the hydroelectric dam. So it's an instantaneous problem all the time right now.
So I have to ask, right, because this is super fascinating to me. You've got 20 years of software development background. You're doing this interesting research. Do you see an inflection point between I'll call it, intelligent software operating parts of the grid? Or where's the nexus there as you're starting to do some of the heavier thinking around this? Anything you care to share there?
Yeah, let me give you just the basics of what machine learning is about. I mean, everyone is waving their hands like machine learning is the greatest thing since sliced bread. And people like me have not really done a great job of getting up and explaining why.
Okay.
So I in my early days during college, I worked summers in a signal processing lab doing research for the Navy. It was part of the MITRE Corporation. Okay. And one of the things we did was we were working on speech recognition.
Okay.
And we had a linguist there, and we were doing our best to lay out what are the rules of language. When we make this sound, what does that mean? How does it fit in these words? How do the words fit together? And so a lot of artificial intelligence, like the Lisp guys, were huge. They were better at making these rules than anyone. And so Lisp was the thing to do in artificial intelligence.
Right.
And we struggled with this for 50 years, right? We've been working on speech recognition forever.
Yeah.
And it turned out that we can't make all the rules. So there's just too many, and they're too subtle. And so instead, what machine learning does is you just feed it data. So to make Google Translate, what Google did is they took the documents from the EU, right, which are translated into 12 different languages, and they just ran it through a computer and said, "Hey, why don't you learn from this to predict this?" And it learned from the data.
Yeah.
And in a neural network, which is this big distributed piece of soft knowledge, we would feed it in, and out would come perfectly translated text. And it was amazing to us. Like, suddenly things took a huge leap forward. We look at protein folding going on now. It's the same thing. Instead of trying to make rules that people make the rules, we feed the data and we let the machine learn from the data. And there's two huge things. And the first one is that it frees the machine from these human conceptions and these human limitations. So we have all these biases. The machine learns from the data, and whatever's in the data is going to do.
Yeah.
And then the other thing is that it makes it a black box to some degree. And we're all working on this explainability. That is, we look at AlphaGo, right, which is the greatest Go playing computer in the world and software in the world. And it doesn't do things that humans do.
Right.
And we have no easy way to ask it why. It's like it's just like, I played 1 billion games, and when I do this move, I win. So I'm going to do this move.
I do feel like you're setting us up for the punchline in The Hitchhiker's Guide to the Galaxy, right? Which was 42, and then they're like, "Well, why?
Why? What was the question?"
And so that's essentially. So it's interesting. It solves the problem, but the actual context it uses for solving the problem is somewhere between here and there, which is in the code, right? That's so wow. Okay, that's pretty fascinating. Now, I know after you kind of finished with Big Nerd Ranch, you had an opportunity to talk to some students. And during a recent lunch, we were chatting a little bit. And one of the more exciting stories you told, I thought, hey, we should definitely tell our audience about this. And I like the way you have titled it. Care to share that?
So I would walk into the classroom as teachers would have me come in and do a lecture. So if you're a international baccalaureate school, you have a theory of knowledge course, and basically the teacher can do whatever they want. So I got invited to teach the theory of knowledge course one day, and I walked in and I said, do not follow your dreams. Everyone keeps telling you to follow your dreams. This is terrible, terrible advice. I said, you're high schoolers. I said, if you first of all, you have no idea what your dreams are. Most of you are just free floating. Yeah. There are about 30% of you who actually have dreams. And those 30, they want to be artists, they want to be dancers, they want performing arts, and they want to be athletes. And if you look in my LinkedIn feed or my Facebook feed, there is nobody on that list that does that as a profession.
Right.
Unless they're being supported by somebody who does something else.
Right.
I said, those are terrible, terrible dreams. I said, don't do that.
Okay.
I said, I go to this fair every year, and it's a Christmas fair, and you walk through, and there's the lady in the back who has all these Christmas pot holders that she has spent the year making. And she sits all by herself, and nobody ever buys her pot holders because, nobody needs Christmas pot holders.
That's right.
And I tell the students, you do not want to be the Christmas pot holder lady of the world, of life.
Yeah, right. Because you have all this stuff, and nobody's really putting demand for it.
Right. Okay. Study skills that when you walk into the room, people say, oh, my goodness, thank you for being here. Like, we're so glad we had this terrible problem, and you are the person who can fix it.
Right.
What happens is people who go to college, they first of all, they study things that are interesting to a 19-year-old. Psychology is sort of a perfect example, right? All the psychologists, there's about 106,000 licensed psychologists in America. So that's sort of how many psychologist jobs there are, 106,000. Right. Every year, we graduate 117,000 people with bachelor's degrees in psychology. We do not need any more psychologists.
Right.
But my advice to the kids is, if you can, study problem solving. About 10% of the population of the world will need to be good at abstract thinking and problem solving. So we're talking about the people who are going to be engineers and mathematicians and architects and economists, doctors. These are places where you're solving hard problems every day. And those people who have those jobs are not going to have to worry about money, right? That's great income. And I'm not a big materialistic guy, but not having to worry about who pays for lunch when you go out for lunch, that's a really great place to be. I've been broke. Yeah. Being broke, you spend a lot of time thinking, how am I going to make my rent? And it gives you a lot of stress. How am I going to
pay this bill? Yeah.
So really good. I don't think you should try to be a billionaire. I've gotten the great honor of getting to hang out with some billionaires. I've been on the yacht. I got to say, it's great.
Yeah.
But it's only incrementally better than being able to take a friend to lunch and not worry about who pays. So the difference between being broke and having enough, that's a huge difference.
Right.
And then the next step up to being a billionaire, that's an incremental improvement.
It's the difference between being able to ride a roller coaster and saying, I own that roller coaster.
Exactly. So it's hard. That's the thing that I have to tell the kids, is that it's hard to do. It's like a muscle. You practice and practice and practice, and you get good at math, you get good at physics, you get good at problem solving, you get good at communication skills for telling people about those ideas. So being a good public speaker, being a good writer, these are important.
Yeah.
It's supposed to be difficult, right? Do not give up just because you got into your university physics class and 30% of the people are better than you, right?
Right.
They did an interesting study where they looked at people who were top-notch colleges who went into natural sciences and then realized they were not in the top half and quit and went into exercise physiology or whatever.
Yeah, chose something else. Yeah.
And then people who went to second-rate colleges and studied those scientists, and they were the same level of ability, but in the lower level college, these people were rock stars, and they went all the way through and were much more successful in their life than the people who became exercise physiologists at Harvard.
That's a good point, because it's almost prepare for adversity is one of the themes that I would kind of say. Do you feel like you were pretty prepared for adversity through your career, like trajectory? Or how would you say you dealt with it?
So I've been through several economic ups and downs. And I can tell you that being a marketing strategist is great during boom times.
Right. Yeah.
When the crash comes, it's really great to be a plumber. Yeah. Like everybody still needs a plumber. It doesn't matter. It's a local thing. They can't outsource it to India. It pays well. So in some ways, that I've always stayed really very practical in my knowledge and what I know, I think has made me resilient, and has made my company resilient. Is that we didn't get into fluffy things, that we always stuck with things that were really needed. Yeah,
like high demand. That's super cool. Now, we were prepping a little bit, and we started talking about things that were interesting. And so I started asking you about languages, because, essentially you've built your career off of programming languages and software development. Yeah. And, I think there were a couple of things. One, I asked you, what are some of your favorites? Why? And then, what do you see happening in the ecosystem of languages? Like what's going to continue to propel that stuff forward?
So as a professional, I've gotten paid to work in about 20 different languages. And they have all had great things about them. Some languages are better at expressing certain ideas than others. So you find yourself gravitating to those. First of all, everyone should learn the C programming language. Everything is built on top of C. It's scary because there's pointers, and it's an old, awkward language, and lots of things that you think should be, strings aren't really in there. That's just sort of an afterthought. So first of all, everyone should learn C. But then there's every language you learn something new from. And I'll tell you about two languages that I find really interesting right now.
Yeah.
So I'm doing a lot of math work in the language Julia. Okay. And Julia is a lot like, so people compare it to Python because people are doing a lot of machine learning in Python.
Okay.
So it's a really nice language for doing mathematical models. There's a lot of different libraries that are available for math stuff. But what makes it really interesting is what's called multiple dispatch polymorphism.
Whoa.
So let me tell you what it is.
PhD word. Yeah. Okay.
In C, you call a function on a piece of data.
Yeah.
And it knows exactly from that name exactly which instructions to run.
Okay. Yeah.
When you have an object-oriented language like C++ or Objective-C, you have the object, you send a message to it, and it may have some arguments. And what it does depends on which object you send it to. So, for example, if you have a window, it has a button and a slider. When you tell the slider to draw itself, it does something than when you tell the button to draw itself, because it did a dispatch of the method on the type of the object you're sending to. And you may be supplied arguments like where it's supposed to draw itself.
Yeah.
It uses those, but it only does the dispatch based on the first object.
Nice.
Julia, you have a function.
Yeah.
You have a bunch of arguments. It looks at all the arguments and figures out what is the right function to call for that set of arguments.
Gotcha.
So it's like when you multiply a matrix times a matrix, it calls a different function than if you're multiplying a matrix times a scalar.
Nice.
Yeah.
Wow. So it's evaluating across the entire matrix.
All the types. So that's a yes.
Is there a word for that? That's
multiple. What I would say, I said it just a moment ago. Multiple dispatch. And a lot of languages have had. Dylan, one of Apple's experimental languages, had it, but they do it really fast. Is what's the amazing part is, Julia code runs nearly as fast as C code, and I think it's going to be a very successful, very important language in the coming years for all sorts of mathematical models and machine learning. So Julia, if you get a chance, it's open source.
Okay.
There's a lovely community around it. It has incredible libraries. If you're doing something with math and you're doing it in MATLAB or Python, you should at least take a look at Julia and try it out.
So
The other language, sorry, go ahead.
Julia as compared to R, right?
Mm-hmm.
Like,
yeah.
how would you kind of describe them in terms of usage and,
so I use R at school, and it's fine. What's nice about R is if you do a lot of statistics, everything is exactly where you expect it to be. You're like, oh, I need to read a CSV file. Okay, there's a CSV function that I use, and then I need to do the mean. It's built into everything, and then I need to plot it. It's all built in. Everything's exactly where you expect it to be. It's not an elegant language at all, though. It's just a sort of
it's there.
It's a piece of glue to hold the libraries together, and
it's like
they're great libraries, and a lot of statisticians spend a lot of time putting the work in those libraries, and they're great. And that there's a glue between them is super, but you don't feel elegant and consistent like you do when you're doing Julia work.
Okay, got it. I understand. Okay.
The other thing is that when a R programmer needs speed, they drop into C++. And then they link that code into the R code. Whereas with Julia, it's fast enough. You can do it all in Julia.
Got it. So you can stay in one place.
Right.
Really? Okay, cool. And then you were going to say something else. I think you were...
I want to talk about another language.
Okay, cool. Yeah.
All right. So Mozilla, the Mozilla Foundation was writing this browser, the Mozilla Browser.
Okay.
And they had a lot of problems because they were writing in C++. And C++ is a very free language. It lets you do a lot of stupid stuff. And we, as a community, there's a place for that, right? There will always be a place for a language that runs really fast and lets you do all sorts of dumb stuff. And C++ is that language. But they had gotten a code base that was big enough that it no longer felt safe to innovate. That everything was so fragile that it slowed their development down significantly. So they stepped back and they said, what's the problem? And the problem was the language. And they said, what if we made a language that was fast as C++ or even faster and was safe, like, I don't even know a good safe language to compare it to, but, and they came up with the Rust language.
Okay.
And when you write Rust, the compiler is incredibly pedantic. It makes you express exactly what you mean in every line. I know it's 64-bit int, and I'm going to put it into a 32-bit int. I know it's the right size, but I'm going to do the error handling and everything. It's incredibly pedantic. But when you're done and it compiles, it almost always runs. That's the thing about the compiler is it's so pedantic. It almost always runs. And the code that you generate is incredibly predictable and safe. So people are using it for a lot of the crypto stuff is being written in Rust. If you're thinking about going into programming with blockchain and signatures and hashes, Rust is hard to beat.
Yeah, it's very fast. Specific. Is that why? Okay. Yeah, interesting. So now we break into, well, what happened this week? And I love this segment of the show, especially because there are some interesting news topics that we get to discuss and you get to issue your opinion. And so the first one that was out that I thought was interesting is that, you mentioned crypto. It's in the news because it's part of the infrastructure bill, apparently, here in the U.S. and they're looking to pass some rules, but all of a sudden a lot of crypto lobbyists showed up, and those rules are changing quite rapidly. Do you have any thoughts on that?
I think this hype is all too much.
Really?
I think the blockchain is malarkey. I keep hearing entrepreneurs being like, "Well, I'm going to use the blockchain to distribute college degrees," and I'm like, why? Nobody wants the blockchain. A blockchain is a brilliant answer to a question nobody had.
Yeah.
I mean, the idea of decentralization.
It's great.
Sure, it's kind of a fun idea.
Yeah.
But honestly, centralized systems are really pretty good. They let you evolve, for example. That's one of the big things. If you take a distributed system, you give everybody their own little piece of it, and there's a protocol by which they talk, you can't innovate on that protocol anymore because you can't get everybody to upgrade.
That's right.
It's such a simple thing, but it's actually a nightmare if you're working in distributed systems.
Oh my gosh, man! I just that is a company right there. I hope you meant
for
that.
Sure. Yeah.
Why won't you upgrade? That should
automatically distribute the software to everybody. And the other thing is that distributed is just hard, and we have a lot of software we need to write, and if the centralized system works, we should just stick with it. And I understand. I mean, who do we trust? Who with our data? Who do we trust with our identity? I hear that, but there are very few problems that actually require the blockchain. And it was a huge deal 2 years ago. Every time you turned around, there was a headline about blockchain. I haven't seen blockchain do anything useful yet. The cryptocurrencies I think they're all going to come crashing down. I don't see a big value. There was a lot of hope when we started. We were like, well, this is going to be an easy way to move money, hold value and move money across borders in a secure, low expense way. But the fact is, transaction costs on cryptocurrencies are very, very high, both in terms of just cost, every time your money goes into Coinbase and out again, but also in terms of the environment. All the generating crypto and transactions between them are destroying the rainforest. I mean, I don't want to sound like a tree hugger, but it's bad for humanity.
Yeah, the carbon footprint is up there. Now
somebody is going to create a cryptocurrency that is based on some sort of a bucket of
backing
commodities.
Yes.
He's going to be like, if you have one Aaron coin, you show up at Aaron headquarters and we will give you a container, and then it will be, an ounce of gold, a container of natural gas, half a ton of wheat and pork bellies and frozen orange juice. Yeah. And that's going to be the stable currency is you'll be able to move that across borders, and we'll find a cheap way to do it. But once again, there's a centralized aspect to that, in that somebody steps up and says, this coin is worth that container of stuff. So you don't need to have a decentralized ledger. You can have a centralized ledger. We'll just hold
because at some point you're going to have the backing for the currency. And I feel like the entire Silicon Valley is probably going to call me after this and be like, well, billions of dollars say no. And I was like, well, those are not my dollars. So but I do feel like legislation is going to be important to set boundaries. And especially as, once again, it's all fine and good that investors can risk money, but once folks start using cryptocurrency and they don't have the financial backing, if there's a run on the currency, then that causes real impact to a lot of the population that may not be as savvy around that usage.
Right. I think that day is coming. We'll see. I've been wrong before.
Yeah, it could.
I actually was one of the very first people to see the web. Yeah. So I was working on a Next computer, which is where the web was invented.
Okay.
And it was late 1991, early 1992. I would imagine only, a couple hundred people had seen the web at the time.
Right.
And this high energy physicist, it was out of CERN, so only the high energy physicist knew about it. He pulled me aside. He's like, look at this thing we have. We can browse the documentation for the CERN accelerator right here in Seattle.
Yeah.
And I poked around at it a little bit. And I said, this is dumb. This is like FTP, but I can only get one file at a time. Yeah, so I could be really wrong about cryptocurrencies. I've been proven wrong consistently.
Hopefully folks aren't investing based on the show, because this is not investment advice at all. And then the next thing that we were talking about was there's something really interesting here, and I thought it might relate somewhat to your work. But there's a new project starting up. It's called the eBPF, and it's kind of focused on kernel level, what I would call I call them micro appliances that could live at in various places. And the best example is Facebook's got I think it's a software defined load balancer that lives on some of its kernel, which makes sense for you want to talk about insane traffic, right? And so
that project has been around for a while. It's definitely getting more mature, and it's getting a larger foundation behind it. So it's great to see.
Okay.
So there's an overhead every time the thread of execution goes from user space into kernel space. And overall, what we've been trying to do, most programmers, is move things into user space so we don't have to go into the kernel very often. So if you look at Google's new operating system, Fuchsia, a lot more stuff happens in user space, so you do not have to go across that boundary. Nice. But this is the other approach, which is, well, as long as we're in the kernel, what if we could do these heavy lifting things before you went back to the user. And so there will be an improvement in performance on a lot of systems because of this. And that's exciting. I don't think it's going to be interesting to the average programmer. Writing code that runs in the kernel is not typically necessary. But people like Google, a small change in the performance of their servers could save them, millions and millions of dollars in power.
Yeah. The next area that I was looking at was someone who was a CEO of a startup spent a lot of time, which makes me wonder, like how he's using his time. Describing his breakdown of the first 2 years. And I was like, oh, well, I don't know, like, I'm interesting. The thing that caught my eye on this one was like, he just tracked everything in his calendar so he could get things out of his head. And I was like, well, that's innovative. Yeah, I get it. But like, at the end of the day, it's an interesting exercise in like, how much overhead do you spend tracking yourself?
Yeah. All right. So I think, most CEOs don't have time to track themselves, but given that he did, this is a really interesting article and you should totally share the link with your users. And here's the one that I love that this teaches you.
Okay.
Strategy. People assume that CEOs spend all their day working on strategy.
Right.
And you don't get to do that. Right? Is that once you have the super tanker running, you make only a couple of really strategic decisions per year. It's true. Nearly everything you do is tactical. You're recruiting. You're keeping people happy. You are saying the strategy a lot. You're like, we're not going to spend time on that because that's not the strategy. And that's the crucial part is good strategy makes people angry. Customers will come to you and they will say, we really want you to teach a kids camp.
And you're like,
and you'll say, that is not our strategy. Big Nerd Ranch is top end. We train Google. We train Facebook. We train Uber. We don't train children. There's a lot of people in that space. We don't want to compete against them. So strategy is mostly about saying no, and it pisses people off. If you aren't pissing people off, you don't have a good strategy. But you only get to make like 2 decisions per year. And then the rest of the time, you're doing really very tactical things. And that's what is interesting about that graph is strategy is a very small slice of his day. And the reason why is because you don't get to work a whole lot on strategy. You're looking around, you're keeping track of the competition, you're looking at opportunities. But no, everyone assumes that we're always doing strategic stuff, and it's once or twice a year we make a strategic decision.
Well, I'm going to say we're about 10 minutes over our time. So so I first of all want to thank you for taking the time out of your day, sharing what interesting things you're working on, and giving us some opinions about what matters and what doesn't. And,
hey, can I do a quick plug?
Yeah, sure.
Yeah, so one of the things that I've been doing in my retirement is as I've been investing. And one of the companies that I invested in, my friend came to the movie theater and he explained it to me as a debit card for kids. I was like, and he said, I have this team. And I was like, that's the right team. That's a real problem. I had kids. And so I invested. I was the very first angel investor in a company called Greenlight Financial. So the Greenlight card is a card that you give your kids, you put money on it, and you can actually specify this pot of money can at least be spent at the Gap. So you know that your kid is buying jeans instead of Robitussin. And it's been a great success. So Andreessen Horowitz just bought in. It's at a $2.4 billion valuation. If you could all use Greenlight card, I'd sure appreciate it. All right.
Nice.
That's my plug.
I like it, man. And I guess as well, it's that is good investment advice there. So
Oh, and if we have an IPO, you should definitely buy in.
Well, hey, Aaron, thanks again. I really appreciate you spending some time on your Friday with us, and look forward to having you back in the future. When you maybe build a competitor Greenlight. I don't know.
No, I'm not going to compete.
All right, take care.
Thanks, Sudesh. It was fun.
Take care. Bye.
Bye.